Okay, here we are with another example of a trig triangle. Integral, we have, this one actually does have bounds, so it's one more step to finding the value of the integral. In this case, we have the integral from square root of 3 to 2 of square root of x squared minus 3 over x dx. First step in these equations is look to see if there's any other way to evaluate the integral. It looks like a u substitution might be doable, but I did try it and it's not quite possible to eliminate the terms. So whenever you have the square root, it's good to look for the trig replacement integrals. So we have square root of x squared minus 3 could be replaced with square root of u squared minus a squared. In this case, u equals x, a equals square root of 3. So x is equal to the square root of 3 secant theta. Since this is the square root function that goes along with the secant replacement integral. So we have a term now for x. Next step, find the dx. So we need to differentiate. Dx is equal to square root of 3 secant theta tan theta d theta. Now we have two terms replaced. Now we need to find something to replace for the square root of x squared minus 3. I'm going to draw a triangle now. In this case, we're going to need to find the third side. Since we know, by rearranging this, we know that secant theta is equal to x over square root of 3. If we flip that to make a cosine, which more people know, it would be square root of 3 over x, which is adjacent over hypotenuse. So that equals x for the hypotenuse, adjacent, square root of 3. Now we need to solve for the third side. I like to call it a. Square root of 3 squared, 3 plus a squared equal to x squared. A is equal to square root x squared minus 3. Since these two terms match up, we know that we did the correct trig replacement. So now we need to find an equation that will include a trig function and the square root of x squared minus 3 without including an additional variable, because we've already replaced it, we don't need anything more to replace it with. So I'm going to do tangent theta, which comes from opposite over adjacent, is equal to square root of x squared minus 3 over square root of 3. If we do some algebra to rearrange that, square root of 3 tan theta is equal to square root of x squared minus 3. We now have values that we can replace all three parts with trig values. Now before we replace these values, it is important to make sure that we have the bounds correctly replaced. We would want to put them into this equation here. Since we're dealing with thetas in all of our replacements, we want to change the x values into thetas. So we say secant theta is equal to x over square root of 3. Start off with the 2. When we replace 2 in with x and take the inverse of secant, we get pi over 6. When we put square root of 3 in for x, secant of theta equals 1. Theta then will equal 0. Okay? Now, to replace the square root of x squared minus 3, we have right here square root of 3 tangent theta, x replaced with the first one we got, square root of 3 secant theta, dx replaced with square root of 3 secant theta tan theta d theta. Square roots of 3 cancel. Secants cancel. We are left with, bring the square root of 3 out front. 0 to pi over 6 of tan times tan, tan squared theta d theta. Now we don't know how to directly take the integral of tan squared theta, so by using a trig identity, I'm going to replace that with secant squared theta minus 1 this we can integrate. Integral of secant squared theta, tan theta, 1 is just theta, with our bounds pi over 6 and 0, and let's not forget the square root of 3 out front. Now we do the second fundamental theorem of calculus. Evaluate tan theta minus theta of pi over 6. We get 1 over square root of 3 minus pi over 6. Let's get some parentheses going here. Minus, evaluate 0. Tan of 0 is 0. 0 is 0. Now we can simplify. In this case, we're going to get 1 minus square root of 3 pi over 6. This is as far as we can simplify it rationally, or the decimal is approximately 0.0931. That's your answer for this trig replacement integral.